So yeah, I'm going to be talking today about integrating SQL data into your Plone site. And yeah, so here's the thing. I submitted this talk because I never get to do tech talks anymore. It's always like, you should do the keynote. And I'm like, great. And I say the same thing every year. And this year I said, I've been building really great stuff at work. I want to show it off, so I'm going to do a tech talk again. And in the interim, I got laid off because we were downsizing. And because of the NDA I signed, I can't show you any of the stuff I wanted to show you. So this may be a much shorter talk, but I built an example product to kind of show off generally what we were doing, try to give you guys an idea. Has anyone worked with SQL Alchemy before? Okay, so great. SQL Alchemy is an object relational model on top of SQL. So it basically turns a SQL database into something that looks more like what we're used to with Python and Plone. Let me give you a short example of what that would look like. If I can get my text editor back. There we go. So SQL Alchemy models will look something like this, where we have where we set up a Python class. We define columns for it. So this one would have a primary key, ID column, a name column, a description, and a price. And let me fire this up so I can show it off. And so SQL Alchemy takes care of the whole bit of, you define this Python class, and it takes care of the whole part of setting up the database backend. I'm using Postgres, but it works with many other systems. Let's see. All right, so now that that's started up, my database is created. You can see I have 4 different tables here. I don't know if there's any way to make this bigger. No. All right, so we just looked at the products table in SQL here, this right down here. And we can see that it created a comparable table in Postgres. So we have the same fields, the integer, the name, the description, and the price. And so we can kind of let it do its own thing in that back-end part and use normal Python to interact with it. So one of the first things we need to do is get a session, which is a database connection. And I'm not going to go into how to set that up because it's kind of boring and a little insane. But so I can get in my session, which allows me to talk to the database, and I can do a query. So we just looked at products. So let's do a query and get the products. And that's going to return a query object, which is just sort of a lazy mapper to what the results are. We can say all and get back all of the results. So my script created two different products in here. And you can see it basically returns just a list of Python objects. And we can talk to individual ones, get that object. We can ask, what's your name? We can say, what's your description? I didn't set one for that. And what's your price? So we can get just regular attribute access. And then we can do things like filtering. And so we can say product.name equals widget wash. And so we just get that one result back. And then we can also do contains call, which would do a much simpler, oh, no, missed parentheses, there we go. So we can do searches just within the text, that sort of thing. It does really great jobs with joins and all that. Let's see. what do I have available right now as an object? So I've gone through and I've created customers for this, a couple products, and I have this order class that I've built. And that looks like this. So we have a basic table where we map customers, which are another class we have, customers and dates. And so we can set up this relationship between an order and a customer. And that provides the references between the two. And once again, it feels very similar to how things work in Plone and in Python. So let's see, we created an order named order, and the order has a customer. And so that relationship gets that. We can also look at the customer itself. Let's see, he's bFurgler. Can I make that bigger for you? Now we've lost it.
Lost it on the right, on the left.
Oh, okay. Here, let me try reconnecting, see if that helps. Okay, all right. Well, I'm just not going to touch anything. So we have our user, bFurgler here, and we can look at his orders because we have that same. So we have the relationship between order and customer, which is called customer. So we can get the customer that's attached to this order, and we can also use this back reference, and so we can get the list of orders that belong to Bert. And so the typical result of that returns this lazy query, but we can do a list comprehension and actually get that order object back. So we can kind of get that data from either side, whether we're looking at the product or the order itself or the customer. All right, so I think that's probably enough on those, but what I want to show is, so what we were doing is we were using a product called Collective Trajectory, and I'm not going to pronounce his name, I'm sorry, which was basically a Plone implementation of Martine's package called Traject, which is basically allows you to do different aspects of routing and traversal, basically using ways to pull data out of the URL and turn it into to take a path and turn it into something we can work with and pull variables out of it. There are three parts to this. There's a pattern, a model, and a factory. The patterns look something like this. So if I happen to have worked for a team or for a project that worked with sports teams, we would have had something that looked a lot like this. Where our patterns, so we were able to basically create a URL that looks something like these, depending on whether we wanted to really enforce text uniqueness for IDs or not. Typically what we had was this, where we get a URL that said teams with an ID of 12, athlete with an ID of 47, and Traject would go through and be able to pull out the IDs and map those to these models. So yeah, we created a mapping, and that would basically fire up a call to a very simple Python object, which took those two URL parameters and turned them into an object. And one of the important things with this talk is that I applied a marker interface to that, and I'll get back to that in a bit. And there's a factory, which just creates the object on the fly. So those look like, so that's the SQL model. We also have a, so this is the Python class, the wrapper, the model that basically just takes an ID and does a database lookup to get the SQL alchemy result for that. And then I created title and description classes that just reference that, pull in the proper fields for those. So when we get this, so the factory, we get the ID that comes in from the pattern down here. This is a very simple one, so we're just taking an ID. We have, I should mention, we have a folder in the site which has this iProduct container marker on it. And all that does is allow us to register this trajectory path against it. So for that folder, anything with a /ID, it'll try to pass through this product factory, which will give us this product wrapper. It's basically a traversable SQL Alchemy object. It still makes my brain hurt, but it works. So we're creating an object on the fly. This object has a marker interface. So we have an object, a marker interface, and we have the Zo component architecture, which means we can do evil stuff. And so that's things like apply views to this non-existent thing. We can use content listing to list these contents. We can do local role adapters, which I did a lot of. I'll explain as long as nobody repeats it. But we had a site which had so teams and athletes, and so an athlete would be a SQL Alchemy content because we needed to use this in other areas of code and within other products. So we wanted to keep it in SQL. These athlete objects had provided local role adapters and had pass plugins, which is Plone's pluggable authentication service, so that they became user accounts as well. So they stored username and password, and so the athlete now had a, was that a question or just, okay. Oh, I'm sorry. The user had basically a profile page that they were given because of these local role adapters were granted owner access to. And then their coaches had a subset of that where they could view only the athletes on their teams, which came from another SQL query. The athletes sometimes had parents who got full editorial rights over the athlete's profile as well. So the local role adapters were extremely powerful, they're extremely confusing as well. Let's take a look at this product. So, okay, we said we have a product wrapper, which is our basically Plone interface to the SQL Alchemy object. We have registered these trajectory adapters, which basically hook into the traverser and allow us to pass along these requests. So let me start this up. And come on, I'm not cooperating. All right, so I'm just going to quick create a new site here. Trajectory, and I have my example product, which if anyone wants to look at it, it's not up to date, but I will fix that within the next 20 minutes. So it's a package on my GitHub, which all this code is in, or will soon be in. So if I install this, it's going to, so we'll create the Plone site, and we'll get a new database in here. You'll notice I have two different setups here, an example database and a testing version. Obviously, we wanted to be able to test all our, so SQL Alchemy can work with SQLite as well, which was great because it was fast and good for testing, but it was also not entirely feature comparable to what Postgres would give us, which is kind of the point. But so we really wanted to test what our live data was going to look like. So we set up so that we weren't writing to actual databases at the time. Yeah. So creating that, it automatically creates this products folder and just a folder with a marker interface applied. If we go into the database and were to, let's see, add a product here. And I apologize, there's no way to make this one bigger. We will add a row. So we'll create a product here. So this lives in our database. And if we go to back to Plone here, so we have that same trajectory path here. So the products folder, which has this iProduct container marker, and then just passing the ID here back to it. And so our product had an ID of 1, and now I look like an asshole.
You added it to the right database because I saw you went into example instead of example testing.
This should be the right one. Wow, okay. Example
No
TV.
pressure.
Yeah, no pressure.
No one's watching.
Right. I tried to chase you all off beforehand, but it didn't work. Let's see. Oh, yeah. It would help if I saved the configures ECML when I reactivated all those views and stuff. All right, so we have our thing, we have there we go. So, okay. So we have our object, and what you're looking at is a view on that object. So we took, because our very simple object that doesn't live in the ZODB has a marker interface, the Zope component architecture can take that and say, you know, we can create a view that goes against that. Oh, come on. It's over there. That's not much consolation for everybody that's over here. Okay. So you'll just have to take my word for it, and you can explain it later. So, all right. So we have a marker interface. We can create a view that works for that marker interface that's on that object, even though it doesn't actually exist in Plone. And so I created a view here that just returns a very simple page template. Okay. This is the most amount of stuff I've had go wrong with a talk yet. This is great, and not just the technical stuff, but the losing a job beforehand. Okay, so yeah, this is our basic view. Our basic view template. All it is the standard main template, and we use the title and description that we already defined on this wrapper object back here. Where's the title and description? So it's pulling out those. And it's just getting the price from the object itself. So there's that. Then what we can do is use Plone App Content Listing. Has anybody really played with this? Okay. It provides basically adapters to say, I have a thing, and that thing will tell you how it wants to be displayed in a folder view. And it's actually really pretty cool. It went into Plone 4.2, I think, and it's really nice. The bad thing about it is that I realized when I was working on this example that when somebody who built the new folder contents view, the really fancy, like click around and do all kinds of stuff in it, didn't use this. It uses a completely different thing. So we will fix that because I'm irritated. But it still works for the base folder views. So if we go back up to this products folder, this is just using the standard listing view. So it's taking that, using that adapter and saying, so now my product knows how to describe itself in this view. And I think that works for tabular listing, I think it is. That's not right. No. Okay. Never mind. That never happened.
The user interface?
Nope. Let's see. Display. Yeah, I'm just gonna type this in because I don't trust that one. I didn't test that. So there, yeah. So it works there as well. Because it doesn't describe a modification date or type, none of that shows up or an icon. But that's something you could obviously do if you have that data available in your database. So yeah, let me see. Where is that defined? So that's an adapter on iContent listing object. So we basically create this product listing object that grabs the it gets passed in the content or the SQL Alchemy content, and we can just go through and try to pull data, check the wrapped object, check the SQL Alchemy object, and some of it we just have to define on our own. So, getting the URL of it, we use the absolute URL and return that. So we have product listing, and we can click in and view it. The other thing we can do is create and I hope I'm not making anybody motion sick with that. We can create a schema for it. And I would love to find out a way to kind of map between the SQL Alchemy definition and the ZOAP schema definition. I have not worked that out yet. But so we can basically take these same fields. So we have our name, description, and price. We define them up here as the same thing, so name, description, and price. And we can use that to create, so how about an edit form? So kind of have to do a little bit of extra work to do the applying changes. So basically we're saying once that data comes in, we want to get the SQL Alchemy object itself and start applying those fields to it. And then we would do the SQL Alchemy bits of committing that back up to the database. Yes.
Can I ask a question?
Yes, yes.
So in line 51, you say form applied changes, and then you apply them yourself by hand. So what happens in form applied changes if you don't have an object?
Right. It doesn't. Yeah. So the question was why do I have this form applied changes? So that doesn't do any actual work to apply changes. So it's wonderfully named. But I think that's also because there's not a real object to push anything to. But what it does do is look at the data that gets passed in. So what gets passed in is compared to what's already there. And it says, yes, there have been changes to the data, so we should do something with it. So that's what the rest of this bit does. So that basically skips all the trying to set stuff and just says, yes, there's changes. And then goes through and we take care of making those changes and then committing them back to the database. And yeah, so I had to add my own handle apply method just because the edit form doesn't automatically redirect back to the view. So what that does is we define that view. We can go in and say edit, and we get an edit form for that. So there's all that. We can change the price to say $19.99. It changes it there. We look at the database, and we can see the prices change there as well. And then you can create a very basic type information, and so this button over here will work as well, which is pretty cool. You can also use that same schema to create an ad form. So we can go in here and say add product, and we now have an ad view that explicitly says go to this view and render this form. So we can create another one, and I'm just going to type things and add that as well. And so we now have an ad form as well, and that should be right there. And that will show up in our listing. So.
I just have a question about your workflow, like as far as, do you create the SQL manually just on, first, and then start to create your Python classes? What about like migrations of changes when you add fields, you change them?
So,
What I've been doing?
yeah, so the question was, what was our workflow? When did we create the classes? When did we create the database? We began creating we were using SQL Alchemy before we got into this pathing method, and we were just using views that did a SQL Alchemy call and had no real. It was all like based off the site route, so it really had no idea of context. So for us, yeah, we had the SQL Alchemy set up before we did any of this. And what was the second half of that? Migrations. Most of that we did by hand, but then we started getting into something called SQL Alchemy, and then the migration thing that Zeke created was Alembic? Yeah. So we were using that, which is really nice because it'll basically take a look at, you can run a script and it'll look at your model and see compare that. So here's my model that I've just added 3 fields to, and here's the database, what's the difference? And it'll create the methods to inject those new fields into the table or remove or whatever. And the nice thing about it is it gives you it gives you a forward path, but it also gives you the ability to write the bit that says, oh, undo what I just did. So, yeah. And where was I going to go from there? I think that's about it. So yeah, basically you can take this stuff that lives elsewhere, you can inject it into your site. Even though it doesn't live there, you can certainly make it look like it does because we provide all the hooks to let you do that. You just have to look for them. And yeah, any questions?
Yeah.
Yes.
Okay, that's really useful. I was wondering if you could take the evil stuff, that mixing two things a bit further. I mean, I guess like this you can index it, your product in the catalog.
I have not tried that.
Indexer would be possible, but it should be just an adapter. Yeah, I guess it would be just an adapter, but the second part.
Oh, I'm sorry. I'm supposed to be handing this out.
Oh, sorry. Yeah, I was.
Hello.
There we go.
I was just wondering if you could take the integration even further and index that in the Z catalog. I guess that's just an adapter.
Mhm.
And but the second thing is what I would find really cool is an ability to have your SQL like objects that live in the Postgres database and store additional information about them in the ZODB. I'm thinking of a workflow state.
Yeah.
So
Yeah.
passing an object through workflow, that would be a killer thing.
Yeah, that's something we really wanted to do. We just did not get to it. But since we had athletes who would retire. We wanted to be able to kind of flip that switch to do that as well. Yeah, and then that would control, because athletes were a profile. That could then control who could log in and things like that.
Did you explore how to do that in any way?
No, unfortunately. But yeah, it should be doable. Yeah. Here, we'll just hand the mic down the row, if you don't mind. Well, Philip, since you're...
Yep.
Sorry.
Sorry, I was a little late, so maybe I missed the part on the motivation. Is there any other motivation except for you already having a huge SQL database that is used in some other context Or is there, I don't know, some huge speed improvements that come at the price of loss of security and workflow and stuff like that?
Oh, yeah, right, we have two. Thank you.
It's great.
Um,
Very slick.
yeah, what was the motivation? Part of it is when I joined the project, they were using SQL Alchemy and Plone, and basically it was more evil. So this was largely my attempt to kind of wrench things back into the Plone world, where things existed in a path, where things kind of worked from the user interface and how more or less how we would expect them to work. Like I said before, everything was previously just based off of browser views that were created at the site root that did things and completely walked around 80% of Plone. Yeah, so we had a lot of pre-existing content, but we also had things where they just didn't make a lot of sense as a ZOP or a dexterity content type. Like test data was one, definitely, where we had, or game data even, we had the NBA dumping in game data from every player, like, this immensely detailed, how much time during the game, during the first 5 minutes they spent running, how much time they spent walking, jogging, standing still, laying on the ground, that sort of thing. And we wanted to be able to access that. Okay, that's probably a poor example because we didn't really need to use that as in a contextual state, but we made heavy use of SQL because we had so much tabular data that we needed to be able to parse and query.
Wolfgang's question about mapping it together with content type is actually possible. So if you're looking into dexterity, you can modify the getter and setter to just do the stuff and write it into the SQL database itself, having it stored, so have the workflow attached from your dexterity content types. And you can even make it so that you use dexterity just as a wrapper without writing anything to the database and writing all stuff into the SQL database.
Okay.
But is that also SQL Alchemy? Or?
Yes.
Oh, great. Yeah, I certainly don't think this probably isn't the best way to do things. It's not the only way to do things, but it is a way to do things. So. Anyone else?
So did you actually try to import this massive amount of tabular data into Plone before?
No. Most of the testing and most of that large amount of data, no, we didn't bring in. We opened it up and did queries, opened it up and did some tabular displays, but it wasn't any sort of integration like this.
Basically what I'm wondering is, at what point would you say this is way too much data to try to get into Plone?
I don't know. That's a good question. And the thing is, this isn't in Plone. This is just kind of being piped through it. Yeah, I don't know where the limit on that is. So, one of the other reasons we did this and had that SQL back set up was because so we were running. I'm trying to think of how much I can really say. So we had a setup where we were running club sites for ski teams, and these are like 4 to 18-year-olds from all over the U.S. That would get into the system, and as they would age or move, we wanted to be able to move them to different servers, or not to different servers, but to different club sites, and each one had their own setup. And so we stored all our users in one database, and use the ability to assign them to teams to kind of be able to move them to others or allow them to be on two different teams. We had people at the national level who were involved in several or across a region. And that gave us the ability to kind of provide a login to all those. And that's something that could have been done with LDAP or things like that, but because that athlete data tied into all the other data we were storing, it made sense to us to keep it all in the same place. Yes?
I have another use case, like for motivation, why you would store things rather in SQL than Plone. We have a project, but it's not necessarily about the sheer amount of data, but for some kinds of queries, just writing SQL queries is just so much more efficient than having to go through a port catalog to do searches. If you want to really have to search for multiple fields and connections about the data types, etc. That's for us one motivation. Like we have something similar with it's I think our last remaining Plone 2.0 site with MySQL storage, using possible archetypes. But the motivation was really then that just back. I don't know. Maybe nowadays the Z catalog is efficient enough, but still doing queries that are really complex with relational data is just very efficient in SQL. That's what it was written for. So that could be a motivation to like hold complex data with many cross-references in SQL and just have Plone do the nice display and add the workflow, etc.
I have another non-question, kind of his line. We've also had a lot more success bringing kind of non-Plone programmers in to do this kind of work, where you have your Python and your SQL, and that's kind of how a lot of Ruby programmers and things like that kind of think about the world, and they don't have to learn about ZODB and all that stuff, and they can just kind of like be set up with a browser view and some classes, and they pick it up really quick. And we've also had a lot of success being able to kind of quickly decide that we didn't want this in Plone anymore, we want to jump over to Pyramid, and a lot of our code just kind of moves really easily with SQL Alchemy and
Right.
just browser views. So, not a question.
No, that's fine. That's fine. Okay. Anyone else? All right. Thanks. Yeah, I promised that I would show. Okay, so yeah, this is where that'll be. Give me 5 minutes, and I'll commit up what I made last night and during the keynote this morning, and as I was standing up here. So yeah, and I'm supposed to show you this. Yeah. Thank you.